Welcome to the SPAG video series. Today, in this video, we're going to talk about configuring Ethernet OEM in a service provider domain. In the previous labs, you would have configured a ELINE service, EPL or ELINE service. We are going to configure CFM on the same ELINE service. So CFM is used to monitor the service, and we will be configuring CFM between R1 and R3, which are the two access nodes. So quickly looking at the R1 and R3 configuration. So I'm going to just quickly jump on to the R3 node here. So R3 node here. First thing is what you would do is you would configure the Ethernet OEM. Right. In order to configure the Ethernet OEM, first thing you would see is the global config, Ethernet CFM IEEE, and then the Ethernet CFM global. So these are the two commands that you would configure. Let me actually configure the global command. I don't see that there. Ethernet CFM global. These two configurations are mandatory. So once you've done that, you would actually go and then configure the domain name. So Ethernet CFM domain pod 1, and then I'm going to configure a level 5 CFM. So that's the reason I mentioned it as level 5. You could configure any other levels that you want. And the service name is pod 1 EVC. So whenever you configure a CFM on a service instance, you need to actually define that EVC globally. So P1 is the EVC which has been defined globally. You would see that Ethernet EVC P1 has been defined globally. And VLAN 100, remember in the previous labs we were receiving customer traffic which was VLAN 100. In fact, if you look at the current config in gig 01, you would see that you are encapsulating, or you're actually matching customer traffic which the customer is sending with a VLAN tag of 100. So the VLAN 100 is present here, and continuity check, you're going to check the connectivity or the ELINE service continuously, and the CCM, the continuity check messages interval is 100 milliseconds. So every 100 milliseconds you'd be sending the CCM message, and the failure detection, the failure of a service detection is 3 times 100 millisecond, which is 300 millisecond. Now gig 01, in order to define CFM parameters, what you're going to do is you're going to define MPIDs on the endpoint. So the endpoint here on R01 is the interface which connects to C1, and then R3 is the interface that connects to CE3. So these are your endpoints, and you're going to associate those with the MPIDs. So you cannot define a CFM config as it is on the service instance. So what you have to do is you need to remove the configuration off. First of all, just takes the service instance configuration off. So I'm going to just do a quick no service instance here, and put the service instance and associate with the EVC that you defined globally. This is the EVC that you defined globally. Right? So you would associate with the service instance with the EVC. You would associate the service instance with the EVC that you defined, that is P1. I'm going to copy the same encapsulation and rewrite commands. There is no change, and also the bridge domain config. Right? Once that is done, now I'm going to configure the CFM. So you would see that you wouldn't see the CFM config when you don't associate the service instance with the EVC name. So once you've done that, you will see the service instance in the red. So I would define the CFM map, and then the domain ID that I've defined was pod 1. So I'm sorry, it's not complete yet. So the domain ID here in the global config was pod 1, and the MPID for this instance, or for this end, I'm going to give it as 12. So if you look at essentially the whole config of Ethernet OEM is, I'm going to define the Ethernet CFM IEEE and then global. So I'm going to enable Ethernet CFM globally, and I'm going to define the Ethernet CFM domain and also which VLAN I want the CCM to be transported in. I'm going to define an Ethernet EVC, and when I get down to the interface or the endpoint, when I scroll down, you see that I remove the service instance, and then I put the service instance back again with association of the EVC, and then I define the CFM MPID. So if you look at the other node, So we do pretty much the same config. There is no difference. It's exactly the same, but the MPID should be different because that's another end of the domain. You need unique MPIDs to be mentioned at two other endpoints. So once this is defined, your Ethernet CFM config is completed. So you're monitoring the ELINE service or the EPL service that you created in the previous lab with the Ethernet OAM. Okay, now once the Ethernet CFM has been defined, now I would like to see whether I'm able to see the remote MPID, whether I'm sending and then receiving CCM messages from the remote ID. So in order to do that, the command that you would use is show Ethernet CFM maintenance points. You can look at the maintenance point both local. The local is the one which you have defined it. Remember, the MPID that you used for the local was 12, so that's the reason 12 is showing up. And don't get misled with the up here. That means that it's not the CFM is up. It actually just means that the direction, the direction level of the CFM is up, right? There is up and down direction both. Right now, we are not interested in the local map. We are more interested in the remote map. So what I'm going to do is I'm going to actually see if I'm able to see the remote map here. When I do here, you can see that I can see the remote map, which is 11. If you look at R11, the remote map ID that I used was 11, and I can see it here. That means that we are able to exchange the CFM messages between R13 and R11. By doing this, we are actually established a CFM session and we are monitoring the service as well. Now that was more of verification whether you're seeing the MPID. You can actually ping the remote map and also check whether the Ethernet OAM ping connectivity works. So the command that you would use is simply you would say ping Ethernet and then MPID, which is the remote MPID, which is 11. And then the domain, I would say pod 1, and service. The service that I had used, just let me quickly check the service. That was pod 1. That's a small pod, not to confuse you. And I'm going to just say enter. So you see that the ping is successful. That means that the R13 is successfully able to ping R11 is using the Ethernet OAM pings. This marks the end of the Ethernet OAM configuration video. Have fun configuring Ethernet OAM in the lab.